Unit 8 is a pretty short chapter, so we are already done three lessons, and now we're getting ready for the test. So this is the Unit 8 review. Again, I really strongly encourage you to either print or have on hand this formula sheet, the sheet that I have presented on the left here. Um, have that will kind of get you the ball rolling, and if you get confused by a problem, it will let you it'll give you a good heads up about it. All right, so let's go ahead and walk through this review, and I'll try to explain myself as well as I can. In May 2002, Gallup poll found that 8% of a random sample of 1,012 adults approved of attempts to clone a human. The standard deviation is 1%. Determine the confidence interval. Okay, so I don't know if we've really seen the word confidence interval, but confidence interval is found on this paper on the formula sheet. It's on the back side, kind of at the bottom. What a confidence interval is the same thing as defining what an average is. So if you recall what that is two standard deviations up and down from the average. So here we go. So in this problem, I see that the average is 8% and that a standard deviation is 1%. So kind of constructing one of those distribution curves, the average goes right smack dab in the middle, so that is 8%. And then we go standard deviations, and luckily for us, the standard deviation is 1. So this would be 9%, 10%, 11%. And then standard deviations going down. Again, standard deviations are 1, so that would be -1, -1, -1. So what average is, or our confidence interval is, if I go 2 standard deviations up and down from the average. So that puts us at 6 and 10. This is our confidence interval. Our confidence interval would be anywhere between 6% and 10%. Okay, the next one is asking us, would we do a survey, an observation, or an experiment? A survey are questions, observations is where you just watch, and an experiment is when you introduce something new to nature. All right, so if 25 people have their blood pressure measured and then measured 1 month later after agreeing to exercise 30 minutes a day for 3 times a week. Okay, so this was introduced. This doesn't happen until the experiment person made that happen. So that person is now doing an experiment. You manipulated the environment to make that happen. All right, so number 3, again, is talking about confidence intervals. And so again, that is going to be 2 standard deviations up and down from the average. So I see that the average in this case is 38%, with a standard deviation of 1.5%. So again, the average goes right smack dab in the middle. So that's 38, right smack dab. And then we go up by standard deviations. Standard deviations in this case are 1.5. So this would be 39.5, 41, and then 42.5. And then we also go standard deviations down. So this would be 36.5, this would be 35, and this would be 33.5. So now going 2 up from the average, so the average is right in the middle. So 2 up and then 2 down from the average gives us an interval that is between 35 and 41%. That is our confidence interval. So you find your average, you go up 2 and down 2 standard deviations. What percent lies within 3 standard deviations of the mean? Again, this is the same idea of this curve. So the average is right in the middle, and then we go up standard deviations. So 1 standard deviation, 2 standard deviations, 3 standard deviations. And we go down standard deviations as well. So 1 down, 2 down, 3 down from the average. These bars have various probabilities or percentages. The first one is 34, next one is 13.5, 2.35, and then 0.15. And then the same exists on the negative portion as well. So this is 34, 13.5, 2.35, and 0.15. All right, so they want to know what percentage lies within 3 standard deviations. Within means 3 up, then 3 down. That's within. So we go 3 up, but we also go 3 down. This is what it means to be within. So it would include the percentages of this 2.35, 13.5, 34, 34, 13.5, and 2.35. That's everything that it would include. So what you do is you add all of those up. That comes out to be 99.7%. And they ask, what is the percent? That is the percent. If they ask for a decimal, the decimal would be 0.997. If they ask for the percent, so it'd be 99.7. All right, here we have a mean, aka an average of 10, and a standard deviation of 1. So 10 with a standard deviation of 1. And they want to know what is the probability, what is the percentage, or excuse me, the probability between 8 and 12. So 8 all the way up to 12. Okay, that's the stuff that is encompassed with 8 to 12. Again, going back to those percentages, this would be 13.5, 34, 34, and 13.5. Add those up. And we come up with 95%. They want this as a decimal, so this would be 0.95. What percentage lies within 2 standard deviations? So within 2 standard deviations means 2 up to 2 down. This is within 2 standard deviations. So what percentage is within 2 standard deviations? that would be 95%. And they ask for a percentage, not a decimal, so it would be 95%. Okay, now we're talking about the correlation. Okay, is it high, medium, moderate, low, or no? And so again, what this difference is this. How close are the dots to the line? If the dots are really, really close to the line, then it would be high. Okay, if the dots are, kind of by the line, then that would be considered to be moderate. Okay, note this has to be a line too. Because looking at this next one, this is not a line. So this next one, same question is, spoiler alert, is going to be no, because it's not technically a line. All right, so low would be, yeah, you can maybe make a line out of it, but the dots are so far from the actual line that it's kind of silly. So that would be kind of considered to be low. And then no correlation is just, it's not a line. The dots are just all over the place, and that would be a no correlation, where it's not a line or the dots are just random. So in this situation, you could probably make a line like that. So this would be really, really low in this situation. Again, the next one doesn't make a line, so it's not a linear correlation. Right here, the line looks like that. Wow, that's really high. Those dots are really, really close to that line. Okay, next we have a mean of 10, standard deviation of 1. And we are looking at least 12. At least 12. That means the least. The smallest is 12. So 12 or larger. So that would be this, and then the stuff that goes off into oblivion. Looking those up, that would be 2, 3, 5, and 0, 1, 5. So at least 12 is going to be the addition of those, which would be 2.5%. They want that as a decimal, so move it 2 decimal places. That'd be 0.25 as a decimal. Okay, within 1 standard deviation. So here we go. There's our average, 1, 2, 3. So 1 standard deviation, 2 standard deviations, 3 standard deviations. 1, 2, 3, down 1, down 2, down 3. Okay, within 1 means 1 up to 1 down. This is within 1. So 1 up and 1 down is within 1 standard deviation. So that'd be 34 and 34. 68%, they ask for the percentage, so there it is. If they ask for a decimal, it'd be 0.68. But they asked for the percentage, so I gave them the percentage. Mean of 10 and a standard deviation of 1. So the mean is 10 and each standard deviation is 1. they want to know between 8 and 11. So between 8 and 11. It'd be those three bars right there. Those three bars happen to be a 34, and a 13.5. Why am I having such a big break part? 81.5. As a decimal, that'd be 0.815. Okay, this is the idea of average, or the confidence interval that we looked at earlier. So this is defining an average. An average is, or quote unquote normal, is the average plus and minus 2 standard deviations. Okay, the average plus and minus 2 standard deviations. So here we go. The average is 140 with a standard deviation of 10. So let's start there. So our average is 140 with a standard deviation of 10. So the average is 140, and each standard deviation is 10 pounds. So that'd be 150, 160, and 170. And then going down would be 130, 120, and 110. So normal, aka normal, is 2 standard deviations up and 2 standard deviations down from that average. So our average, what is average, is everything in between 120 to 160. That is quote unquote, in this case, normal. Okay? Then everything on the outside of that would be considered to be heavy. If you're more than 160, or light, which would be under 120. And so John comes in at 115 pounds. 115 is below the 120, so John would be considered to be light. All right, here we go. A mean or an average of 10 with a standard deviation of 1. At most 10. At most 10. What that means is 10 is the most. So everything less than 10. So in this situation, that would be everything less than 10. Every bar less than 10. And there's 4 different segments. That'd be 34, 13.5, 235, and 0.15. Which comes out to be 50%. As a decimal, that is 0.5. Okay, now again, we are going to define what quote unquote normal is. And so that's going to be the average plus and minus 2 standard deviations. So here we see that the mean is 100, that's the average, with the standard deviation of 15. Okay, so 2 standard deviations up, 2 standard deviations down, puts our edges at 70 and 130. That is what quote unquote normal is. Everything outside that, in this case, is considered to be smart and unintelligent. Okay. And Jane comes in at 125. 125 is just a little bit below that 130, so Jane is considered to be normal. All right, so here we go. We have a mean and an average of 10, standard deviation of 1. And they want to know at most 9. At most 9 means 9 is the most. So at most 9 would be 9 and less. So seeing where those things fall, that would be 13.5, 2.35, and 0.15. And that comes out to be, I have to break out the actual calculator this time. 16 flat. They want this as a decimal, so that would be 0.16. Move the decimal 2 places right now. So that's that. Okay, moving on. This should be the last page. Okay, those dots are crazy close to the line, so that's really high. It doesn't matter if it goes uphill or downhill. Okay, that would determine the positivity or negativity. But those dots are really, really close. So that'd be really, really high. Here, I can't even come close to drawing a line, so that has no linear correlation. Those dots are just crazy all over the place. Here we have an average and a standard deviation. So we have an average of 15.6 and a standard deviation of 1.2. So 1.2 would be 16.8, 17, 18, and 19.2. Going down would be 14.4, 12.2, excuse me, 13.2, my bad. And 12 flat. They want to know what is the quote-unquote confidence interval. Confidence interval is the average +2 to -2. So that would be from 13.2 to 18. That's your confidence interval. Okay, last but not least, we are asked to find the mean, median, and mode of this data. The mean, median, and mode. All right, so the mean is where we add them all up and divide by the number of numbers. Actually, before I do this, I'm going to put these numbers in order. Nope, not the smallest. 78 is the smallest. put them in order. So, all right, so here we go. Mean is where you add them all up and divide by the number of numbers. So I'll use my calculator that I have here off screen. I literally add up 78, 81, 78 plus 81 plus 82 plus 83 plus 88 plus 91 plus 91 plus 91. Add them all up, and that comes out to be 685. And then I divide by the number of numbers, and I see that there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. So this comes out to be 85.625. They want this only to 2 decimal places. The 5 is big enough, so that would be rounding up to a 3. So this is 85.63. That's the mean. The median is the middle. So this is going to be 1, 1, 2, 2, 3, 3. All right, so the middle would exist in the middle of 83 and 88. Again, when it's 2 numbers like it is here, what you do is you add those numbers up and you divide by 2. This is all on that formula sheet, kind of on that front side. So again, I will do this work off camera here. So that's 83 plus 88, divide by 2. Last but not least is the mode, and the mode is the one that is there the most, and this is obviously 91 because there's 3 of them, which is way more than anything else. So 91 is that mode. That is our review.